So we just spent quite a bit of time quadratic functions. How can we tell if something was a quadratic function? Well, it had an x squared in it. That's what made it be called quadratic. So what did we do with these things? Well, we graphed. And then we stated a bunch of their properties, and we found equations of them if we were given the graph. Okay, now what we're going to do is we're going to take a look at quadratic equations. What's a quadratic equation? It is a second degree. Degree refers to the highest exponent you see in the equation. Okay, so second degree, which means contains an x squared term. Looks like this. Very, very similar to standard form of a quadratic function. Ax squared plus bx plus c not equals y or equals f of x, but actually equals a number, 0. So remember, quadratic equation, or sorry, quadratic function, we talked about a couple of forms. We say we'll write it in standard form. Y equals ax squared plus bx plus c. But to convert it to a quadratic equation, we actually make this equal to a number, and usually it's 0. So a quadratic function becomes a quadratic equation when y is replaced with a number, usually 0. Everything else is the same. So how do we solve quadratic equations? Well, we spent a lot of grade 9 and part of grade 10 solving linear equations where there was no exponent. It was like 2x plus 7 equals negative 15 or something like that. And you'd move things away from the x until you got x by itself. We do things a little different with quadratic equations. And it all depends on how the quadratic equation looks. When we solve a quadratic equation, the answers are called solutions. But you will also see this quite a bit. Don't confuse this with square roots or cube roots. If you are asked to find the roots of an equation, that's the same thing as solve it. Okay, that means the same thing. There's 3 different ways we can solve quadratic equations. And it all depends on what the quadratic equation looks like to begin with. The first one, which we're going to do today, is something called the square root property. We use these to solve pretty simple quadratic equations. However, if they're a little bit more complex, we may have to solve them by something we did a lot of last year, factoring. And then something called the zero product property. we'll talk about that later. We need to do a review of factoring first. But there's sometimes we get a complex quadratic equation and we can't solve it by factoring. So we need another method. And this is a formula you're going to learn and you're going to remember for the next couple of years, something called the quadratic formula. Again, we'll talk about that later down the road. Okay? But we're going to start with the square root one today. And you guys have actually used this one before. Every time you use Pythagoras, a squared plus b squared equals c squared, you were solving a quadratic equation. Because didn't you always have to take the square root at the end to find the answer? Okay? So you were actually solving quadratic equations. You just didn't know they were called that. So for example, but this is something you got to be careful with because I'm afraid I have lied to you for the last 2 years. If we did Pythagoras, and let's say you ended up with something like 3 squared plus 4 squared equals x squared. Let's say we had to solve that. What would you do next? Yeah, an add, right? So what's 3 squared plus 4 squared?
9 plus 16. 25.
Good. And then what would you do to get the answer for x? Take the square root of 25 and you get 5 and life would be wonderful. Except there's another answer. There is another number that when you take the square root, that there's another answer when you take the square root of 25. There's another number that something times itself gives you 25. Can you think of it? Really? What times itself gives you 25? 5. What other number times itself gives you 25? It's very close to 5. It's almost identical to 5. Negative 5. Okay? So, technically, when you solve these things, the answer could be positive 5 or negative. So we write it like plus minus. So it could be positive 5 or negative 5. The reason that we never did negative 5 when you guys learned this is because the triangle side can't have a negative length. That's why we didn't do it. But now we're introducing it. So now my guilt is gone because I've confessed that I've lied to you the last couple of years. So, if x squared is 16, how would you find what x is? Just the square root of 16? The positive and negative square root of 16. Because the square root of 16 can be 4, because 4 times 4 is 16. So it can be positive 4, or it can be negative 4. So there's 2 answers. Okay, so if x squared is equal to some number, then x will always equal the positive and negative square root of k. Or one of your answers will be positive square root k, and the other answer will have a negative in front of it. So just like we did here, now when you're solving these equations, don't just go square root 16, go plus minus square root 16. How would you solve this one?
17.
What's that?
17.
Okay, so move
move the negative 17 over, yes?
And then, again,
Minus square.
X equals plus minus square root 17.
not just square root 17. Because your answer could be positive or it could be negative. Now, remember, we've been dealing with radicals this year where we haven't used a calculator, have we? We've left our answers as radicals.
Can I simplify this? Is there a highest perfect square that goes into this? 17? No.
I don't want a calculator answer, I want the exact answer. Because as soon as I plug it into a calculator, it gets an approximate answer. So this is what I want you to get used to now.
Let's do 2 more. Well, we've got x squared by itself, so how would you find x? Plus minus square root 45.
Now the question becomes, do I leave that or can I simplify it?
Yeah, this can break down to root 9 times root 5, which means my final answer is going to be plus minus 3 root 5.
So sometimes you're not going to get a whole number for an answer. You're going to get a radical, and you may have to change it to a mixed radical.
How about this last one? Divide both sides by 2. So I get 11 over 2. Don't put a decimal, leave it as a fraction. So x is going to be plus minus root 11 over 2, and I can't
Do anything with that root 11 over 2. I can't simplify it or anything. So I'm done. So when the quadratic equations look pretty straightforward, not too much in them, we use the square root property. But some quadratic equations are more complicated, and we'll address those later. Okay, that's all I got.